Hello everyone, now I am going to explain you about power contactor holding circuit with push buttons. I am going to explain this concept by using two circuits, circuit number 1 and circuit number 2. So on the screen you can observe this is circuit number 1. In this circuit you have a motor. So this is motor and we are giving a three-phase supply to this motor by using MCB. This is MCB and power contactor. This is power contactor and these are push buttons. We are giving three-phase supply to this motor by using a combination of MCB, power contactor and push buttons. Now let us have a basic understanding about power contactors and push buttons. So this is power contactor. In power contactor we have a coil. We have a coil with terminals A1 and A2. This is A1 and this is A2. And we have terminals L1, L2, L3 and downwards we have another set of terminals T1, T2, T3. So when we energize this particular coil through these terminals A1 and A2, these terminals L1, L2, L3, these are in open condition in normal case. In normal case, these L1, L2, L3 contacts are in open condition. When we energize this particular coil, these contacts L1, L2, L3 gets closed. So this is the basic function of a contactor. Now coming to the push buttons. This is start push button. Start push button is generally NO, normally open. When we press this start push button, the circuit gets closed. NO gets converted into closed condition. And stop push button. Stop push button is NC, normally closed. In normal condition, it is in closed condition. When we push this stop push button, the circuit gets opened. So this is the basic understanding of power contactors and push buttons. Coming to the functioning of this circuit, I am supplying three-phase supply to this motor. So I would like to control this supply by using push buttons. For this, what I am trying to do is, I am taking one phase. Let us assume R phase. I am taking R phase from these three phases. So observe this arrow. I am connecting this R phase to the stop push button first, and after that I am connecting this R phase to the start push button, and after that I am connecting this to A1 terminal, one terminal of the coil, and the other terminal of this coil A2 I am connecting this to neutral as shown. So basically I am trying to give single phase supply to this coil for energizing it. Now let us start the push button. I am pressing this push button. When I press this push button, this normally open contact gets closed. When I press this start push button, this circuit gets closed and the single phase supply is getting supplied to the coil. Now the coil is in energized state. As the coil is in energized state, this L1, L2, L3 contacts gets closed and the power supply, three-phase supply goes to the motor and the motor starts running. So the major disadvantage of this circuit is, I have already told you that I have pressed this start push button. So when I release the start push button, the circuit again gets disconnected. The single phase circuit gets disconnected because I already told you that start push button, when I press this, the circuit gets closed, and when I release the start push button, again the circuit gets opened and the supply to the coil gets disconnected and the three-phase supply also gets disconnected. So this is the practical disadvantage, and we cannot keep on holding the start push button continuously for a long time. So we have to do something to hold this circuit. For that, I am going to do a small change in the circuit. Let's go to circuit number 2. This is circuit number 2. In this, circuit number 2 is same as circuit number 1 but with a small change. The change is, observe this purple line. I have connected this purple line. I have connected a wire from one end of the start push button to the NO contact. So this is NO contact of a contactor. The meaning of this is, when I energize this particular coil, this NO contact gets converted into closed condition. This is the function of this NO contact. So I am giving one connection to the NO contact from one end of this start push button, and the other end of the start push button I am connecting to the other end of the NO contact. This is the other end of the NO contact. Basically, I am creating a parallel path for the current. Now what happens is, when I push this start push button, the circuit gets closed here and the coil gets energized, and this particular NO contact also gets closed. The power supply is, three-phase supply is getting supplied to the motor. Now when I release this start push button, still the power supply goes to the motor, because I have created a parallel path. Observe this purple line. After pressing this start push button, the coil got energized and these contacts L1, L2, L3 and NO got closed. So even when I release the start push button, nothing happens to the power supply, because the single phase supply is already having a parallel path as shown in this figure. See these arrows? The single phase supply is having a parallel path through this NO contact. Even when we release the start push button, the supply still goes to the coil in this direction through this purple line. So the coil keeps on getting the coil gets supply continuously, and in this way the three-phase supply is getting supplied to the motor continuously. So this is how a power contactor holding circuit works, and this is the major advantage by using this holding circuit. And if you want to disconnect the power supply to the motor, you need to do one thing: stop push button. You just need to press the stop push button. If you press the stop push button, the normally closed contact gets opened and the single phase supply to the coil gets disconnected. In this way the three-phase supply also gets disconnected. So this is the basic concept of power contactor holding circuit. Thanks a lot.